Hey guys, this is Miss Bufford. I just wanted to go ahead and produce one extra video to help give you some more examples on these limiting and excess reactant problems. So in this particular problem, it says I've got 2 moles of propane that react with 8 moles of oxygen gas in a combustion reaction. How many moles of carbon dioxide are formed, and how much of the excess reactant is left over? So the first thing I want to do is I want to pull all the information I have for this problem out, and I want to write it underneath everything in my chemical equation. So this chemical equation is balanced as it is. All right, and so I have 2 moles of propane, and I'm going to make my pen a little skinnier. 2 moles of propane here, and it's telling me I have 8 moles of oxygen. Right? And it wants to know how many moles of carbon dioxide are produced or formed, right? So in order to solve this problem and get the correct answer, I'm going to have to perform at least 2 stoichiometric calculations to answer this first question right here. So the first stoichiometric calculation I'm going to perform is I'm going to perform one from oxygen to carbon dioxide. And this is going to tell me what the theoretical yield of carbon dioxide will be if I start with 5 moles of oxygen and I have endless amounts of propane. Then I'm going to do a second stoichiometric calculation from propane to carbon dioxide. And this will tell me how much carbon dioxide I can produce from 2 moles of propane if I have endless amounts of oxygen. All right. And then we will be able to look at the results for how much I can have for each one and be able to know which one is my true theoretical yield. Because remember, the limiting reactant is going to produce the true theoretical yield. That's actually how much you could potentially produce given these 2 amounts of each reactant. So let's go ahead and set up our first problem. I am going to start with my 2 moles of propane, so C3H8. And because I'm already in moles, I do not have to convert using a molar mass. I can just go ahead and set up my mole ratio. And my mole ratio here is going to be 1 mole of propane, so C3H8, for every 3 moles of carbon dioxide. And I want to set that up so that my moles of propane will cancel out. So I'm going to put 1 mole of propane down here at the bottom, and my 3 moles of carbon dioxide up here at the top. And I'm going to put this in the calculator, and this tells me that I have 6 moles of CO2. I'm able to produce 6 moles starting with 2 moles of propane. All right, now I'm going to start a second calculation for my 8 moles of oxygen. All right, and since I'm already in moles again, I can just go ahead and set up my mole ratio. And my mole ratio from oxygen to carbon dioxide is 5 moles of O2 for every 3 moles of CO2. And so I want to make sure that I put my oxygen on the bottom, so my 5 moles of O2 down here, so it cancels out. And I have my 3 moles of CO2 up here. And if I put this in my calculator, and if I'm paying attention to significant digits, then this says I can produce 5 moles of CO2. And I actually wish I would have made this correction ahead of time, but let's pretend this is 8.0. And if it's 8.0, let me pull up my calculator here, then 8 divided by 5 times 3 is actually 4.8. Oops. All right, I need to get rid of my calculator. All right, so I'm going to go ahead and make a correction here because there's a point later where it's really important. So 4.8 moles of CO2. All right, so what this tells me is that my smallest theoretical yield right here, that is going to be my true theoretical yield. I am not going to be able to produce the 6 moles of carbon dioxide because after I produce this 4.8 moles of carbon dioxide, I will run out of oxygen. So I won't have enough oxygen to produce more than 4.8 moles of carbon dioxide. All right, which means that oxygen is limiting. All right, so that is the answer to this first question. How many moles of carbon dioxide are formed? Well, we formed 4.8 moles of carbon dioxide. Now, the second question says, and how much of the excess reactant is left over? Well, in order to figure that out, I have to know how much of the propane was used up in this reaction. And in order to calculate that, I have to do one more stoichiometric calculation. And I'm going to start with the amount of my limiting reactant and calculate a new theoretical yield for my propane. All right, so this is going to tell me how much propane it takes to completely react with all 8 moles of oxygen. So I'm going to start with my 8 moles of oxygen, and we're going to say 8.0 moles of O2. And since I'm already in moles, I can go ahead and set up my mole ratio. So my mole ratio here is going to be 5 moles of O2 for every 1 mole of propane. All right, so let's go ahead and write that down here. I want to put my moles of oxygen on the bottom and 1 mole of propane on top. And if I put this in the calculator, that tells me that 1.6 moles of propane are used in the reaction. All right, so 1.6 moles of propane are going to be used up by that 8 moles of oxygen. And if I started with 2 moles of propane and I used 1.6 moles, I'm just going to subtract that from what I started with. That means I have 0.4 moles of propane remaining, or left over. All right, so this right here is the answer to the second question. All right, I hope this video was helpful. Please let me know if you guys have any other questions. I'm happy to do some more examples for you guys in class on Friday if we need to, but I will see you then.